A nice introduction. Hi everybody, I'm Mr. Auerbach. I'll be your science teacher today. And we're going to go over working with atomic symbols. And the two that I'm going to do, and then after that you all can shout out any ones that you would like me to work on, are the two uranium ones. Many people noticed that there were two of them that are uranium, and they give you different pieces of information on each one, so I'll write down what we have for each one. The first one, it does not give the name, it gives the symbol, and it gives the mass. It does not give the atomic number or the number of protons or the number of neutrons. Mitchell, you're at a disadvantage because you missed this yesterday. Have you ever had any of this atom stuff? Protons, neutrons, electrons? No. No. Okay. This is going to be a little bit more difficult for you, but the atom is made of two parts, right? We have the nucleus in the center. By the way, should I believe you that you really haven't, or are you just saying that?
I really have.
Okay, all right. Okay. You have the nucleus in the center, and then you've got what are called the electrons that kind of go around in an orbit on the outside. The nucleus and the electrons are attracted to each other because the electrons are negatively charged, and the nucleus is, or the protons in the nucleus.
Mr. Auerbach.
Yeah.
It is just like missing. Like I swear I had it.
So.
It's just like missing. I honestly would not have taken all that time to look for it if I didn't have it. So.
Okay. And then in the nucleus, we'll talk about it. In the nucleus, you have these things called protons, which are positively charged, and they attract each other, which is what keeps this spinning around. The other thing is that since they're positive and negative, there's always the same number of negative electrons as there are positive protons. That's one thing. Another thing, is there anybody else that wasn't here yesterday? Since I'm just, yeah. We had another student out yesterday. But also in the nucleus are these things called neutrons. And I'm just making them filled circles because they don't have any charge. Sometimes there's the same number as there are protons, sometimes there's more. Neutrons or neutral, they don't have any charge. So that's sort of the basic. And then there's this relationship of the numbers to really quickly state the rules, so you've got a fighting chance here today, Mitchell. There's always the same number of protons and neutrons, or electrons. The mass number is the number of protons plus the number of neutrons. And if you want to figure out the number of neutrons, that's equal to the mass number minus the number of protons. Okay, so there's that, and so I'll start with that. We'll see how it goes from there, and I'd be happy to fill in any other blanks there. So all right, so these were the pieces of information on this one. And then on the other one, it tells you, this is the one that's right here. It says that it's uranium. It doesn't give you the atomic number. By the way, the atomic number, Mitchell, if you look at the square, like if you look at uranium, which is sort of down in one of those bottom rows in the periodic table there, that one, you'll see that there's a symbol that stands for it. there's a number here. That's called the atomic number, which is really just the number of protons. There. You've been taught all of atomic science in about 45 seconds. I'm sure it makes perfect sense. I'm sorry. But we'll catch you up. It doesn't make sense anyways, is that what you said?
It wouldn't have.
Well, anyway, we can talk about it more later. Okay, so this one they give you neither the symbol, nor the atomic number, nor the mass number that goes here. They also don't give you the number of protons. They also, oh wait, the one thing they do give you is the number of neutrons, which is 141. Okay, so that's our starting point. How on earth are we supposed to figure out everything that goes in here? It's not that hard. Between what they give you and your periodic table, you can figure this out. Okay. So, alright, let's do this one with the least amount of information and see how we figure it out. First of all, it tells us the name, uranium. And so, if we intrepidly search our periodic table for the word uranium, nitrogen, oxygen on the bottom, uranium, there it is, number 92. And so we know that the symbol is U. We know that the atomic number is 92 because that's what goes here. The atomic number goes here, number 92. And since the atomic number, oh, I didn't write that up there. The other rule is the atomic number is the number of protons. I did write that over here. We write a 92 there. Now we have everything we need. I can't believe I just did that. We have everything that we need to know in order to figure out the rest of this. So we know that there's 141 neutrons. Sorry. And we know there's 92 protons, and the mass number is the number of protons plus the number of neutrons. And so if I just add these together, works out to be, if I'm not mistaken, 233. Yes? No? Maybe? People with calculators and better brains than me? Okay? Okay. So, are there any questions about that one? How any of that came to be? Okay.
I was using my calculator because I didn't know.
Okay.
I thought that it all had to be 2.
Oh, okay, right, because this one said 238.
So I switched it to 97.
Oh, really? Yeah, no, you can change this. That's the thing. The mass number and the number of neutrons can change. Neutrons are like, what neutrons are really doing? I want to go over here. Well, I'll just do it over here. Fine. Did anybody, I bet nobody thought about this. The mass number, by the way, all it really is, it's the mass of the particles in the nucleus. Each proton or neutron weighs 1. But did you ever wonder why, if all protons are positive, well, if positive and negative attract each other, what do positive and positive do? They repel each other. That's right. Positive and positive, like two magnets that are facing the wrong way, they'll fly apart if they give them half a chance. So why is it that you've got all these positive charges in the nucleus without the whole thing flying apart? Well, let me tell you. That's what neutrons are for. People figure that neutrons, here, I'm going to draw another proton in here. Oops. Neutrons are sometimes called the glue that holds the whole thing together. Because it turns out that protons really do repel each other very, 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 very strongly until they get just the right distance apart. And once they get just the right distance apart, they attract each other more strongly than any other force in nature, called the strong force. It's the basis of nuclear power and nuclear weapons. Because now, once they're, as it turns out, exactly about 1 neutron's width apart, they can't be separated very easily at all. And so the neutrons are kind of like the glue that keeps this whole thing together, which would otherwise fly apart. I feel like our society could use some neutrons. Anyway, okay, that was ridiculous. That was dorky. But anyway, can't we all just get along?
Sir Armand,
Yes?
what makes the neutrons like stay where they are?
They're neutral. They don't care where they are. They go where they're told. I guess. I don't know. I've never thought about that. Because they're neutral, nothing moves them. Protons and electrons react to each other because they're attracted.
On their own.
That's I don't. What's that? Well, there is. I will tell you. You want to know something interesting about neutrons? Here's something interesting about neutrons that I bet nobody knew. A neutron is actually made of a proton and an electron together. A neutron is really, if we dissected a neutron, what we would find inside, just inside that blue shell, they aren't really blue, what we would find is a proton and an electron together. And because it's positive and negative in the same particle, it makes it neutral. That's going to come into play later. But anyway...
So what color are they really?
Yeah, they don't know what color they are. No one knows. The thing about neutrons is that you can have different numbers of them in the same atom. You can have different masses because they're not protons. The protons are the thing that if you have different numbers of protons, it becomes something else. If I had 93 protons, it would be... I don't remember... Neptunium. If I had 91 protons, it would be protactinium. But anyway, let's not talk about that. Let's do this one so you can see how you can have different numbers of neutrons and it's still uranium. Okay? I'll stand over here so the camera can see me. This is my good side. I'm so sorry. Okay, so what do we have? All we know... So you guys, this is like a game of deductive reasoning. You take what you know and you deduce what you don't know based on the information you have. So all we know now is that the mass number is 238, and then it's uranium. We don't have protons, we don't have neutrons, we don't have the atomic number, we don't even know what the name is. If you look for the big U on the periodic table, you find uranium. That part's easy. And then you also see, as I said before, that uranium is atomic number 92. Without that, it wouldn't be uranium. And so, since it's number 92, that means there's 92 protons. And the very last piece of information is the number of neutrons. I remind you of rule number 2. The mass number is the number of protons plus the number of neutrons. Therefore, if you want to know the number of neutrons, you subtract the number of protons from the mass number. So 238 minus 92 gives us 146 neutrons. And so different numbers of neutrons, so it's just sort of like there's a couple extras in there. It doesn't make any difference. They still act the same way. If I have a sample of uranium, which I'm going to show you later, in that sample of uranium are some atoms with this many neutrons, making it what we would call uranium 238. Notice how it's named after its mass number. And this one has this many neutrons, making it uranium 233, a very rare isotope of uranium. These are isotopes. Isotopes are different versions of the same element that have different numbers of neutrons. There's also uranium 234, which has one more neutron, and uranium 235, which is, well, it's the most relevant in the sense that this is what leads to atomic power and atomic weapons. Okay, so that's the 2 uraniums. Are there other ones that people would like me to do on this sheet? The other class made me do some other ones. Do I like them more? Is that what you just said?
No, I said we're not the
You're not the other class. It's true. You want me to do Mercury? I'll do Mercury. You're just doing that. You're just doing that to make me happy.
We want you to do it.
You guys.
We support
No,
you.
do plutonium. There you go.
Plutonium? Okay. I'll do plutonium. Well, you finish your homework. Okay. Alright, I'll do one more. Plutonium. Plutonium is the most toxic substance known to humankind. I am pretty sure, I don't know if this is really true, I'm going to say it on film anyway. 1 gram of plutonium divided up amongst all of humankind would kill all of us, I'm pretty sure. That's probably massive misinformation. I don't know if that's really true, but 1 gram of plutonium could kill lots and lots and lots and lots of us, spread out amongst all of us. Really true. Really, really,
Where
really
is
true.
it found?
divided that much.
I'm concerned about this question. How would you do that? I don't know. I don't know. I think I'm gonna, hold on.
Put it in the water.
Hey, plutonium.
That's what you'd have to do, like put it in the ocean.
Put it in the water. Any like water
Maybe.
system.
You all are
Let's
scary.
not do that.
You all are scary. Let me tell you what.
Someone's
Alright.
taking notes.
PU is this one. So they don't give us anything on this one either. They give us, and by the way, you're going to have to do this when we have our test on this. Among the many things you'll have to do is this kind of problem. So they don't give us the symbol, they don't give us the mass, they don't give us the atomic number. This they do. They give it to us. It's 94. They give us anything else? They give us the number of neutrons. They say 150 neutrons. They don't tell us how many protons, nor do they tell us anything else. So, okay, first thing, you see this number, the atomic number is wrong piece of paper. You go to your periodic table and you look for this atomic number. Yeah, Pu, 94. So it's Pu, and that is plutonium. The rest of it, well, first of all, if it's 94 here, it's going to be 94 here, because the atomic number is the number of protons. And then finally, the mass number is the whole nucleus's mass, 94 protons and 150 neutrons. This is 244. Plutonium 244. And so there you go. Okay. I will stop the tape now.